This diary will contain all the topics for network theory. So please listen and see carefully. All the best.
So today we will start with topic 18, that is maximum power transfer theorem. MPT, or let me write it full form, maximum power transfer theorem. See, it is like, you can say that it is like an extension of Thevenin's theorem. It is not a terminology that is used in books, but yeah. So what it states is, okay, let me write down the statement. It will be fine. So this is the statement, that is in Thevenin equivalent model. In Thevenin equivalent model, remember this: if a variable load, see, I have written, because this is most important thing. This is the thing that usually people forget while doing questions. There has to be a variable load, then only you can apply maximum power transfer theorem. Okay, if the load is not variable, then you can't do this. Okay, and there are many problems in GATE on this concept. Then there will be maximum power transfer to the load when RTH is equal to RL. That is, see, this RTH and VTH, I have found out that this is the Thevenin equivalent of any given network. So maximum power transfer will be to this, maximum power will be transferred to this RL, that this is load resistance, when RTH is equal to RL. That is, when the value of this RL will be RTH, then maximum power will transfer to this load, which will be given by this formula, VTH square by 4RL. You can easily derive this. Please see the derivation from books. It is unnecessarily time consuming. So I will draw the curve. This you should have in mind. Like, this is P, this is RL, that is, this is load resistance. So the curve moves like this. This will be P max, and P max will occur when RL will be equal to RTH. So this is the curve. Now we will see one problem based on this question. And one thing you always remember, that when variable load is connected, this is the most important part in this theorem. Okay, so how to approach this question? First, you have to find the Thevenin equivalent across this load resistance. Okay, so how to find Thevenin equivalent? I have told you there are 3 methods, but here we can apply only 2 methods, any of the 2, because method 1 or method 3 we can apply, because there is a dependent source. Okay, so first let us find out the Thevenin equivalent of this network, looking from here. Okay, so I will find out, let me use method 1. So in method 1, you just don't have to do anything. You have to find out this current, and you also have to find out the VTH. So yes, and for power maximum we need VTH square by 4 RTH. So we have to find the VTH also. So first we will find out the VTH. Let us say this is VTH. Okay, so VTH will be what? There will be no current flow, so VTH will be 100 volts. It's simple. See how simple this question is. See, the current won't flow here because there is no path. This is open circuit, and this is a dependent source, so it cannot generate any current itself, because there is no voltage drop here, Vx. So this won't work also. So my VTH will be equal to 100 volts. Okay, now what we have to find the RTH. So I will use method 1. In method 1, what we do, we short circuit this and we find out this current. So RTH will be given by VTH by ISC. Okay, so now find out this current. So to find out this current, what we can do, let me assume this as a reference node, see, and the voltage at this node will be 100 volts, because the source is connected. Or you can apply KVL in this branch. I have told you a number of times how to apply. So this is 100 volts. So the current through this branch is, let me assume the current is flowing in this direction. So current will be 100 divided by 8, because this is a reference node. So current through this branch will be 100 by 8 amps. And the polarities will be, that I have assumed, will be plus minus plus minus. Okay, So my this from using my assumed polarities, the voltage drop across this 4 ohm resistor will be 4 into 100 by 8, that is equal to 50 volts. But my assumed polarities are different from the given polarities, so this means Vx will be equal to minus 50 volts. So this is minus 50. Okay, so now we can also find the current in this branch by applying KVL in this branch. So this is 100, this is 0, so I have to, as I am finding 100 minus 0, so I will move from this to here. So this will be, let me say the current is flowing like this, I, this will be plus minus, so this will be 100 is equal to, this will be plus 4i minus Vx. Okay, so 4i minus 50, that is 100 is equal to 4i plus 50, 4i is equal to 100 minus 50, 50, I is equal to 50 by 4. And so the current ISC will be equal to this 50 by 4 plus this 100 by 8. So what it will be, 100 plus 100, that is 200 by 8, that will be equal to 25 amps. So ISC is coming out as 25 amperes. So my RTH will be equal to what? VTH is 100 volts, ISC is coming out 25 amperes, so my RTH will be equal to 25 4 100, 4 ohms. So that's how I have found this RL. So for maximum power transfer, this RTH should be equal to RL. So my RL comes out to be 4 ohms. Now for maximum power transfer, what was the condition? What was the maximum power formula? P max is equal to VTH square by 4 RTH. So VTH is 100 square divided by 4 into 4, as RTH is 4. So 100 into 100 divided by 4 into 4, 425, 425, 25 square. What will be 25 square? Let me do 25 square. 625 watts. So this is the answer. That is, this is the maximum power transfer to the load when RL is equal to 4 ohms. So that is how you solve the questions for maximum power transfer. Always remember, maximum power transfer, there has to be a variable load to apply it. Okay, and then it is simple KVL KCL. Please watch the basics that I have videos that I have made till now, because there I have anytime I have explained how to apply KVL, how to take the polarities, because these are things that usually most people confuse. Okay, so that is how you assume your polarities, and I have told you many times. Okay, thanks, bye.